Welcome to BTEC Revision. In today's lesson, we're looking at friction. By the end, we should be able to calculate static and kinetic friction using the coefficients of friction. A force is an interaction between objects that causes a change in motion, direction, or shape. Let's start by looking at the change in motion. If we take ball 1 and it's moving with a velocity of 10 meters per second, and in order for it to move to 20 meters per second, we would have to apply a force. Let's take ball 2, and the direction is towards the right. If we want to change the direction down, then we would have to apply a force. Let's take ball 3, and in order for the ball to change shape or deform, we would also have to apply a force. Let's look at some examples of forces. Here we have weight of the ball, it's pulling it down, that's a force. And what's stopping it falling into the ground is the normal force. Let's take ball 2 and place it in water. Now, drawing the forces, we'll have weight going down, just like before, but this time we are going to have up thrust. We take ball number 3 and place it on a very slight slope, then it's experiencing a force of weight, which is going to have a component dragging it down. And in this case, if it doesn't move, then we will have a force called static friction. Static friction is a force that prevents the object from moving, and this is keeping this ball in place. Let's say the ball starts moving with a constant velocity. Now, the friction is going to be called kinetic friction. Kinetic friction is the force that arises due to motion. And we can calculate static friction or kinetic friction using this formula below. This frictional force is going to be equal to the coefficient of friction multiplied by the normal. Something to note here is that the coefficient of friction could be due to static friction or kinetic friction. The short form for this equation is F, which stands for frictional force, equals mu, which is coefficient of friction, multiplied by the normal N. And there would be two versions of this equation, one for static friction, which we can write as F of S is equal to mu of S multiplied by N. And this is for static friction. The second equation is for kinetic friction, which can be written as F of K is equal to mu of K multiplied by the normal. The units here for frictional force are Newton, because force is measured in newtons. The normal force is also measured in newtons, so that means the coefficient of friction is unitless. There are no units for the coefficient of friction. One very important point to note is that the normal should be perpendicular to the ground. For example, if we have the ground here and we have an object, then the normal force is 90 degrees to this ground. And if it's at a slope, then the normal force is drawn at 90 degrees to the slope here. For static friction, if I have 1 Newton of force acting against it, then the static friction is going to be equal to that 1 Newton. If I increase this to 2 Newtons, then static friction is going to be 2 Newtons. And this is going to happen until the object starts to move. For kinetic friction, let's say there is a force of 20 Newtons thrusting this object forward. Then kinetic friction is always going to be the same value. So let's say that is 10 Newtons. So it doesn't matter if the force propelling this forward increases or decreases, the kinetic friction will always be the same. Now let's try this example. We have a 10-kilogram box and it's resting on a horizontal surface with a coefficient of friction, static friction of 0.4. So we can start by drawing the diagram to make the question clear. So here's our box. We have 10 kilograms and that's going to have a weight due to gravity, which is 10 times 9.8. So that would be 98 newtons. What's the maximum horizontal force that can be applied to the box before it starts to move? So we're going to use this equation, and since it's not moving, we're going to apply the force due to static friction, and coefficient of friction is due to static coefficient of friction, and we can plug in our values. Okay, so we got mu s, which is 0.4. We have our normal force, and since this object is not going up or down, we can say that the forces are balanced. So therefore, the normal force must be equal to 98 newtons. So we can multiply 0.4 with 98, and that gives us a value of 39.2 newtons. Now pause the video here and attempt this exam question. The first thing we should note here is that this block is stationary and it's on a slope. And we can start by looking at where the normal is going to go, which is always perpendicular to the slope. And here we have the weight, which is 100 newtons. And we should note that these lines, the weight and the normal force, are not aligned with each other. So we would want to work out the component of the weight so that it is aligned with the normal force. And using geometry, we can see that this is an angle, 20 degrees, matching that to the slope and the ground. Using trigonometry, SOHCAHTOA, we're going to use cos theta equals adjacent over hypotenuse. Rearranging for A would give us a value here of h cos theta. We know h is the longest side, which is 100 newtons, times by cos theta, which is 20 degrees. So the normal force is matching that of the component perpendicular to the weight. So what do? We can equate them because this object is not going up or down in comparison to the slope. So therefore they must be equal. So you can say that the normal force equals 100 cos 20 degrees. Now we can plug this into our equation, which is going to be F, and in this case, static, that's equal to mu S times the normal, and that's equal to 0.4 times 100 cos 20 degrees, which is equal to 37.59 newtons. For the second question, the object is now moving, and it's moving with constant velocity. So we can ignore static friction. And in order to calculate, the question is asking for the frictional force. We would want to work out the kinetic friction first. So if we write down the equation, kinetic friction equals coefficient of kinetic multiplied by the normal. We can plug in the value 0.2 and we have our value for the normal from before, and that's 100 cos 20. And that would be giving us a value of 18.79 newtons. Now, what is this telling us? If we have a force going down along the slope, that must be equal to the force going up along the slope if this object is either stationary or moving with constant velocity. So that means that the frictional force is 18.79, which is equal to the force pulling this object down. So that's just some extra piece of information to note here. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com, where there's lots more resources. I'll see you next lesson.